Hey everyone, this is me, Code Sensei, and welcome to my YouTube channel. Today we are going to see how to solve the coin change problem using the dynamic programming approach. So let us look at the problem statement. Given a value V, you have to make change for V cents. Given that you have an infinite supply of each of the C valued coins, which will range from C1 to Cn. Find the minimum number of coins to make the change. For example, if you are given a coin set of rupees 1 and rupees 2 and the amount you need, total amount you need is 7, your answer should be 4 because you can make use of 3 2 rupee coins and 1 rupee coin. And similarly, for the coin set of 9, 6, 5 and 1 and for the amount of 11, the answer will be 2 because you can use 1 6 rupee coin and 1 5 rupee coin. Let us take the example of the coin set 9561 and the amount 11. We need to find the minimum number of coins for sum is 11. So, how can we approach this problem? We can look at this way. We have to find the minimum coins required if we pick each of the coin. I think you will be able to understand this better if you take a look at the next slide. So, we know that our coin set consists of the coins 9, 6, 5 and 1 and the amount that they require is 11. So, uh, how can we solve this problem? You have to think of these problems. You have to divide it into many sub-problems. For example, we have to consider if you can take the coin 9. So if you take the coin 9, the remaining amount that you should find that you will have to fill is 2. That is 11 minus 9 is 2, right? So you have to find the minimum number of coins required to make the amount 2. Similarly, if you take the coin 6, the remaining amount will be 5 and you have to find the minimum number of coins you need for the value 5 and then add 1 to it. And the same if you take the coin 5, the remaining amount will be 6 and you have to find the minimum number of coins to uh, you needed to get the sum of 6 and you have to add 1 to it. And the same if you take the coin 1, you will have remaining the sum of 10 and for which we have to find the minimum number of coins to make the sum 10 and add 1 to it. And out of all the obtained values, what the answer should be the minimum of uh, the minimum of these values, that is the minimum of number of coins to make 2 or number of coins to make 5 or number of coins to make 6 or number of coins to make 10 plus 1. So you can see there is a recursive pattern in this solution. You can see that the minimum number of coins to make the sum 11 is nothing but 1 plus the minimum number of coins to make 2 or 1 plus 1 plus the minimum number of coins to make 2, 5, 6 and 10, and that will give you the final solution. So for this recursive solution, the base case must be that we all know that the number of points required to make the value 0 is 0, right? So whenever you get 0, you will return to the subproblem. That is, you will count the number of edges. So there are two edges in this tree. So the minimum number of coins required to get 11 is 2. You can the order of the solution doesn't matter, and there can be many branches that will give the minimum value like this. You can either take the coin 5 and 6, or in the reverse order you can also take the coin 6 and 5, which will both make the sum 2. And if the sums are negative, I mean we are calling the value for negative values, we are calling the function for negative values, it should return -1, which will mean that it is impossible to uh, get the value 11 using the combination of 9 and 9, or 9 and 6, or 9 and 5, and so on. So this is how the solution will work. So let us look at the pseudocode for the problem. I'm sure that currently you'll be extremely confused about the solution, but don't worry, in the upcoming sections of the video I will teach you each and every step on how to solve this problem with a much simpler example, so that you will understand a lot better in the upcoming section of the video. So this is the pseudocode for the problem. As we saw earlier, if the amount is less than 0, I'm sorry, here this should be -1. If the amount is less than 0, we will return -1, because it is impossible to get negative value, right? And if the amount is 0, we will return 0, which will mean that it is possible to get that value. And we will initialize a variable minimum, which will equals infinity for now, and for each coin in the coin set, we are going to take a temporary current variable, which is going to find the uh, minimum number of coins required for the if we take the current coin. For example, in our example, 11 was the total amount. So after that, we will, for the first coin in the set was 9. So the we are taking the coin 9, right? So the coin change will be called for amount minus coin. The amount is 11, so amount minus coin is 2. So this function will be called recursively for the value 2, and thus it will give the value for that set of coins. And if that is less than the minimum value so far obtained, uh, we will add one coin to it, which is nothing but what we saw in the previous slides. We will add one coin to it, because for getting 2, this is the minimum number of coins required. Then for getting 11, you have to add one coin, right? That is this 9. So we are going to change the minimum value as the number of coins required to get 2 plus 1. That is, if the number of coins needed to get value 2 plus 1 is less than minimum. And while looping this, we will finally find the least number of points that is needed to make the sum, and then we will return that as a solution. So the time complexity is big of amount to the power c, and space complexity is big of amount. So can we do better? Can we think of a better solution? Uh, in dynamic programming, there is a concept known as memoization. In computing, memoization is an optimization technique used primarily to speed up computer programs by storing the results of expensive function calls and returning the cached result in the same input sucker again. So memoization is nothing but caching, or it's like storing computed values in order to avoid further computations of the same values. Uh, you will get a better understanding why we will use this in the upcoming slides. So consider the amount of 4 and coin set 1, 2 and 3. When you draw the recursive tree diagram, you can see that there are overlapping function calls. That is, the function call is repeated for the same value again and again, which is nothing but a waste of computer's time because we are recomputing the same thing again and again. So, in order to avoid recomputation, what we can do is we can store the value for this in an array, right? And so whenever if you encounter that one again, we can first check into our memory and see if the value for this is already stored, and if it is not stored, then we can compute it, or if it is stored, we can directly get that value and use it in our program. This will save us a lot of time because a lot of repeated computations are being cut off. So for this, we know that leaving aside the negative values, the function calls for the coin change problem will range from 0 to the amount that we need. So, for example, if you see this tree, you can notice that the positive function calls for these are 0, 1, 2, 3, and 4. So, we will create an array of size amount plus 1. Amount is 4. So, amount plus 1 to store the values for each amount. So, this will be the array, and initially they will all be initialized to infinity except for the amount 0, because we know that the number of the minimum number of points needed to make amount 0 is 0, obviously, right? So then uh, let us make a dry run through our program. First we need to get the value for amount 4, right? So we will have three function calls. The first function call will be for 3. So the first function call will be for 3. Now in 3, in this function, the first function call will be for 2. And then in 2, the first function call will be for 1. I hope you all get how this is happening, because this is if the coin value 1 is taken, coin 2 is taken, and coin 3 is taken. So 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1, and 1 minus 1 is 0. So finally, the last, the base of that tree we will get 0. So we already know that the minimum number of points required for 0 is 0, and these are negative, so these are not required for us, and they will just return a value of -1. And coming to the problem, so for one, the minimum of these is except for you should not take -1 into consideration because they mean that it's impossible. So the minimum here is 0, right? So for 1, the return value should be 1. 1, which means 1 minimum coin is required to make the sum of 1. So we will go to the array and change the first index to 1. And now coming to this part again, we need not take into consideration this. So 1 will take the minimum number of coins for 1 is 1, and minimum number of coins for 0 is 0. So the minimum of this is 0, right? So we will add 1 to it. So the minimum number of points to get the sum 2 is 1. So we will change the second index to 1. And then similarly, now we have to find it for in this one, in this subtree. So from the array we can see that the minimum number of coins required for 2 is 1, minimum number of coins required for 1 is 1, and minimum number of coins required for 0 is 0. So the minimum of these is 0, right? And since and so the number of coins required to make the sum 3 is 0 plus 1, which will be 1. So in the third index of the array, we will change the value to 1. And then finally, we have to take this level. The minimum number of coins required to make the sum 3 from the array can be seen as 1. And for 2 it is 1, and for 1 also it is 1. So the minimum number of points, so the minimum of these three values is 1, right? So to obtain the sum 4, we have to add 1 to the minimum of these values, which will make up to 1 plus 1, which is 2, which will be the final answer. That is, if we have the coin set 1 consisting of 1, 2 and 3, the minimum number of coins required to make the sum 4 is 2. So we have to change the value of this as 2. And then we will actually return the final value 2 to our as the return value of our function. And this is how this is the top-down approach of how to solve the coin change problem by using dynamic programming method. So this is the pseudocode for the problem. It's almost the same, except for we are adding a cache in which we are going to store the computed values. That is, if they are not infinity, we are going to return the computed value. If it is infinity, it means that they haven't been computed yet. So thank you for watching this video. If you like my videos, you can like, comment and subscribe to my channel to see similar videos. And if you want me to solve any problems, you can comment below, and I'll try to solve those problems and upload videos for them to happy coding. Bye.